welcome to the DOE lectures. This lecture we will primarily concentrate on pairwise comparisons. So, last class we ended with test of assumptions. Test of assumption means normality test, homoscedasticity test, independence and identically distributed test. So, I will quickly go through now on the residual plots, and then we will come for we will concentrate on pairwise comparisons under this Tukey test, and Fisher's LSD. These two tests will be discussed. So, let us see the first that each rate data, and we have developed the ANOVA model, and finally, we computed the residuals, like in the first cell 23.8 is the residual, second cell minus 9.2, like this. In this table you see that there are original of y value values, there are residuals or estimated error values, and there are run orders within first bracket in which order the experiment was conducted. So, first we will see the plot of run order versus residuals. Run order versus residual. This plot gives you an idea about independence, whether the observations collected through the experiment are independent or not. See the plot. So, in the left hand side the plot is run order or time or the observation order, and y axis is residuals. You see the plot shows random pattern. There is no pattern, it is a completely random one. So, if this is the case, then it is independent. The observations are independent in nature. You see the right hand side plot where is the predicted value versus residual also. This also showing there is no pattern. It is purely a random one. So, this one not only this one gives another another proof for homoscedasticity assumption also. There is no pattern in the data. There is no funneling right to left. Okay. So, now as you have seen that the ANOVA hypothesis is so that mu 1 equal to mu 2 equal to mu a. This is basically null hypothesis, the all means are equal, or we say tau I equal to 0, that is no treatment effects. An alternative hypothesis is that at mu I not equal to mu j for at least one pair of mu's, or alternatively tau I not equal to 0 for at least one I. Okay. Suppose ANOVA this ANOVA says that ANOVA through F test shows that there is significant difference in one or more pair of means. So, ANOVA through ANOVA table through F test, what we can observe either there will be no difference between pair of means or no treatment effect, or there will be at least one pair of means that is different. So, one or more pair of means will be different, and that means there are one or more treatment effects. Now, if there are a number of treatments, so what will happen? You can have AC2 number of comparisons. SC2 number of comparisons of means basically. So that means mu1, suppose 3 a equal to 3, then comparison will be mu1 versus mu2, mu2 versus mu3, and mu3 versus mu1. So that means 3 pairs of comparisons of means there. Why this pairwise comparison is essential? Because of this. So if there is one or more pairs which are different, then ANOVA that through F test will not tell you that which pairs are different. It will tell you there are one or more pair of means they are different. So in order to know which pair is different, you require test for this mu1 versus mu2, mu1 versus mu3, and mu3 versus mu1. The question is then why not then independently you test mu1 versus mu2, mu1 versus mu3, and mu3 versus mu1 from the data itself without doing ANOVA beforehand. Then what will happen? What will happen? There will be errors. Error because you cannot test separately this. Here the pairwise comparison will make and and that the error will be adjusted. Okay. So that's why the special kind of test, this Tukey's test, Fisher's LSD test will be used. Okay. So let us see the hypothesis for the pairwise comparison, that mu I minus mu j equal to 0 and mu I minus mu j not equal to 0. So we'll see Tukey's test and Fisher LSD test. What is Tukey test? Tukey test actually first there will be a statistic called Q, which is known as studentized range statistics, which is y bar max minus y bar mean by root over ms e by n. You see all the quantity or right hand side is known to you. What is y bar max? You have a number of treatments, so you have a number of means or average here from the experimental data. So there will be a mean average value which is maximum, there will be another one minimum. So the difference between maximum of the average and the minimum of the average values for all the A treatments, that is the difference divided by MSE. MSE is mean square errors, which already you have computed. So that by n, this is a statistic which basically will be used by Tukey to develop the pairwise comparison test. Okay. So you see what we have to consider here. We have considered out of a group of p sample means also, p number of sample means. So then two means are significantly different if the absolute value of their sample difference exceeds this. So there is a threshold value T A, which is q alpha a f root over of this quantity. Now A is the A, you all know that the number of treatments, and MSE also known to you, and N is also known to you. Now F is another quantity which is required to be known, and then the 100 into 1 minus alpha % confidence interval for all pair of means will be yi dot bar minus yj dot bar minus q alpha a f root over this and this. So if sample sizes are not equal, then the other formula will be used. Okay. Now see the example, the ground clutter example. So y1 bar, y2 bar and y3 bar computed, 90, 96, 99.25, this is computed. So then the difference in average that y1 bar minus y2 bar is this, y1 bar minus y3 bar is this, and y2 bar minus y3 bar is these differences are computed. And then from Tukey test you just find out, see what happened, what is the threshold value. Threshold value is q alpha a f root over mac by n, then q 0.05, alpha you have considered 0.05. There are three levels of there are three treatment levels, and 21 is coming from the errors degree of freedom. Okay, as I told you, you require to know the f value. What is f value? F value is the error degrees of freedom, because for this example there are 24 there are 24 observations, 18 to 3 24 observations, then total degree of freedom is 23, then treatment degree of freedom is 3 minus 1 2, then error degree of freedom is 23 minus 2 equal to 21, which is also f, consider here f. So if you put this value, this will be 11.12. Now you may be interested to know that how are you getting this q 0.05321 value. This value is available from the chart developed for this Tukey test. Okay, so there will be table or chart available to you, and if you follow Montgomery, then what you will see that at the in the appendices that the Tukey's test, these values are given. So what we have done, we have basically taken q 0.05320 alpha 2021, that value from the Tukey, that appendix, and then this is multiplied, and finally you got 11.12. Okay. Now this is the threshold value. So if any pair pair differences like y1 bar minus y2 bar, y1 y3, these differences, that in absolute value they are more than 11.12, then we consider that pair is different. But if you recall the ANOVA, that overall test, that there we found that when we consider only ground clutter levels and there is no difference in the means ANOVA test itself says there is no difference in means. So the pairwise test is not required, but we have done the pairwise test in order to show you that even from the pairwise test also we are finding out that no two pairs are pair of means are different. So no two pairs in every pair, that is mu 1 mu 2 mu 2 mu 3 and mu 3 mu 1, no pairs showing any significant difference. Okay. So but if you recall the second example where the each rate for at the 4 level of are a power factor. So what you have found out that the ANOVA overall test says that there is significant difference in means, maybe at least one of the means is different from the other means. That is what we found from the overall F test using for ANOVA. Now then we were interested to know which pair is different. So as in the power example there are 4 levels, treatment levels. So how many comparison possible? Mu 1 versus mu 2, mu 2 versus mu 3, mu 3 versus mu 4, then mu 2 versus mu 4, then mu 1 versus mu 4. So mu 1 mu 2, mu 1 mu 4 and mu 1 versus mu 3, then mu 2 versus mu 3, then mu 2 versus mu 4, mu 3 versus 1 2 3 4 6. So that means 4 C2, 6 pairwise comparison, 6 pairs you are getting, 6 pair of mean differences. So now see here. So, we found out that T alpha value, which is Q is 0.05416, and this value is 33.09. Now, when we compare all the means, you see that all the 6 pairs, that first one is minus 36.20, second one is minus 74.20, like this. So, if you see the absolute value for all these, you see that none of them are less than 33.09, all are more than the threshold value. So, it says that there is significant differences in means, which is proven by the overall test. From pairwise test also it is further confirmed. So, that means here interestingly all the mean differences are significant, but there may be situation when you find out that some of the mean differences will be significant and some of the mean difference will not be significant. And in the previous example, we found that all the mean differences are not significant, and here all mean differences are significant, and there will be in between. So, some other example may give you this kind of results. Okay. So, the same test or same thing you can do using Fisher least significant difference method. LSD stands for least significance difference. Okay. Here what is done in this case, we use T test, which is very popular test, and it is known, data tables are available. So, Fisher LSD is easier method to calculate or to test or calculate and to test whether the means are different or not pairwise. So, you see T0 yi bar minus yj dot bar by MSE by into this, and this is nothing but the basically what you have seen earlier, that the difference this in confidence interval test we found out the difference between two means, two averages, and using these statistics we found the confidence interval for two difference between two means, and there we have also seen this kind of, this is the variability of this. Okay. Now, then LSD value, the threshold value is T alpha by 2 n minus a. What is n minus a? That is the again error degrees of freedom into this. Okay. And if your ANOVA is balanced, mean the sample sizes are equal, then what happened? This quantity will become 2 by n. So, 2 MSE by n. So, if any pair absolute value of any difference pair, any pair is more than the LSD value, threshold value, then that will that means that pair is significantly different. Okay. So, here again in cluttered data you find this one we already computed, and LSD value 9.17. You see none of these values in absolute term are more than 9.17, only y1 dot bar and minus y3 dot bar are this value is this value is basically close to 9.17, but anyhow as it is less than 9.17, we are saying that is no mean pair of means are different. Okay. And the same will be proven, and it is also done, and we have computed and found that even using Fisher LSD also you are finding out that in the power example, in the each rate data case, that all the pairs are significantly different. Okay. So, this is what is pairwise comparison. So, in nutshell, let me tell you that conclude the one way ANOVA part, one way ANOVA. So, what we have done, one way ANOVA mean there will be only one factor such as your each rate such as your power in each rate example ETCH each rate example, or your ground clutter in case of that radar scope example, okay, there will be one factor, and that factor will be having different levels. So, suppose in general if you say the factor is A, so A with A labels 1, 2 like A labels. What does it mean by level? These are all treatment level. For example, in case of ground clutter, A equal to 3, that is low, medium, high. In case of power, that is rate data, A equal to 4, that is 160, 180, 200 and 220 watt. Okay. This is the first thing. Second is that obviously you will conduct random experiment, complete randomized design. Okay. Then your ultimate hypothesis is you want to test H0 mu 1 equal to mu 2 dot mu A, or you tau I equal to 0, alternatively mu I not equal to mu j or tau I not equal to 0. This is the test, and you have ANOVA model with data ANOVA model. So, there will be mean model and there will be the complete model, parametric model and mean model will be there. So, that means y I j will be mu plus tau I plus epsilon I j, or it can be written mu I plus epsilon I j, and this epsilon I j is normally distributed with mu sigma square and homoscedasticity. Okay. And obviously sum of tau I equal to 0, and then there are a lot of assumptions for ANOVA, and assumptions are basically, that is normality assumptions, homoscedasticity assumption, independence and identically distributed, that assumptions will be there. Okay. So, those assumptions all must be fulfilled, otherwise what will happen, data may be the results may be erroneous. But anyhow, ANOVA is robust against normality, but if there is homoscedasticity problem, it is the data heteroscedasticity, it is difficult. Okay. So, then what happen, you have what you partition you basically partition the data into different components, then sum square also total is also partitions into sum square treatment plus sum square error. Then here the degree of freedom is n minus 1, here degree of freedom is a minus 1 plus n minus a. Then you have developed ANOVA table, and from there in the table the sources of variation is important, then SS you computed, then you computed degree of freedom, then you computed MS, then you computed F equal to MS treatment by MS error, and this quantity follows F distribution with a minus 1 and n minus a degrees of freedom. You find out a minus 1 and n minus a alpha some threshold value, this is the threshold value. If computed like F0, if computed F is greater than the threshold value alpha, then you are rejecting null hypothesis, rejecting H0. Okay. So, you reject H0. Then once you reject H0, the pairwise comparison is important. Once you reject H0, you are interested to know which pair is different. Rejection of H0 case gives you which pair is different. So, there you have used Fisher LSD, least significant difference, and we have used Tukey's test also. Okay. And in addition, in the test of assumption, some amount of residuals plots are there, parameters and all those things. So, this is in nutshell the one way ANOVA. And now, let me acknowledge that this lecture is prepared based on this book, Montgomery, Design and Analysis of Experiments. Thank you very much.